Alright, so what we're looking at today, the first part of what we're looking at is what we call transforming data. So in this course, what we do is we look at linear associations, and if we suspect that there's an association that's not linear, then what we do is we change our data, or we transform our data to get a straight line. So for scatter plots that are non-linear, transform the data. Alright, so we change it, excuse me, we change it to get a linear, so to linearise. A-R-I-S, stupid word. The scatter plot. And to narrow it down, we use the circle of transformation. And this is the circle of transformations, and I think hopefully I've sent one of those to the printer, which I'll just go run and get now.
While we're waiting for these documents, make sure to like and subscribe.
Like and subscribe. Sam said it.
I said it.
Good on you, Sam. Nice work. Alright, here is the circle of transformation.
Do you know what I mean? Like it's more noticeable if you don't.
Alright, so there you've got the circle of transformations, and as you can see, so it's like a circle, here's our circle, and these would be like scatter plots. So if the scatter plot curves like this way, in this part of the circle, then our possible transformations are these ones, y squared and x squared. Similarly, if it looks like this, part of the circle, then here's our possibilities for transformations. So, an example might be something like this.
Yes.
Thanks, Ben.
And they are on YouTube.
Alright, so if we've got our scatter plot, so we've got our x, our EV, and our y, which is our RV, and if we get the plot something like that, then you might say, okay, well this seems to look like it goes in a bit of a curve like so. If we put a line that goes through those points. And so what we do is we look and see it's curving round like this. So we'll come over to our circle of transformations and a bit that curves like that. There's this section up here, and so we've been given 3 options. Alright, so plot that we've got here looks like the top left of the circle. So what we try then one of these 3, so y squared log x and 1 on x transformations. And then we would look and see which one of those fits it best, and we would use our correlation coefficients to help us there. Right. All right, we need to do an example. Can I?
No.
Yeah, sorry.
No, I can't. All right, I won't. I will leave that there.
Is there more information than just what you put there? Because I don't understand what you mean by that.
That's why I'm going to do an example, and then I'll show you more in the example. Alright, am I right to rub that off now or not?
Yes.
Thank you, Rory. Alright, this sheet I'm going to, again I forgot to print it, so it's on its way to the printer. And seeing as number 5's a good bloke, he's going to go and get it for us. Good on you, number 5. Alright, so calculator is what we will use. Statistics, is that the right ones? It's not the right ones, so let's clear it all. Alright, example. This across. Make sure we've still got the right thing here. Alright, so the example is this.
How big is this example? It's alright, don't worry.
Page and a half. Depends.
Page.
Alright, so the table shows the height in metres of base jumper for the first 10 seconds. So we've got time. And then we've got height. So when we start, and then 10 seconds. All right, so there's the information. Is that printed out?
And you hand them out?
And he's handed them out as well.
Thank you.
What a terrific bloke there, number 5.
What is number 5 there?
What's number 5? He's boron.
Different when you do physics.
Yeah, everyone gets the joke when you do physics. Ready?
We're in a math.
All
I
right.
have too many numbers.
So, first of all, what are we going to do? We've got to construct a scatter plot. All right, so we're looking at scatter plot. We have a look at that and see what it looks like before we decide whether we need to transform it. In this example, we will have to. But we still need the scatter plot to see what that shape is so that we can then refer to our circle of transformations. So that we're not just doing any random things. Alright, so linearise and fit a scatter plot, or at least a squares line I should say. Transform the data. And then the last thing we're going to do is we're going to use our regression line to predict the height of the jumper after 3.4 seconds. All right. So the first thing we need to do, or do I need to give you more time to write that down?
I didn't even see that you'd written the questions. That was.
Need more time? Right.
So just double checking this to Synno. We definitely don't have a SAC this term.
Wouldn't think so.
Are we doing a topic test like the other class?
Probably.
Okay, you just didn't tell us about that one.
No, it's only a topic test. What's the matter? You've been doing topic tests all along. Little mini tests. Progression things.
Do we know what day that'll be?
No, haven't given any thought to that.
That's right. You could just not give it any thought till next term.
Any thought till next term? Because we've got a whole bunch, when we finish this bit, the regression analysis and the residual analysis, we've got all of what's known as time series to do, so before the SAC, so it's extremely unlikely given that we've got how many more weeks? 3? Extremely unlikely that that's going to happen. All right. Okay, so on the handout there, this one, that one, this one here, this handout has walked through exactly this question. All right, so unless you are told otherwise, tables always have our explanatory variable here and our response variable here. Right? It's always the case, unless you're told something different, which is not overly likely, however may happen. All right, so we're using our calculator. You can see there now I've already put the time there. Now I need to put the heights. Then alright, so list 1 and list 2 again. Eventually we'll get there. Should have prepared this early, but anyway, we'll manage. Alright. So in list 1 we've got the time, list 2 we've got the height above the ground, I'm guessing. So we need to construct a scatter plot. So go through the few different ways that we can do this, but what we also need, as it shows on here, shows that I'm gone to the calculate menu and the regression and the linear reg. Now the reason for that is because we need the information that that's going to give us for when we then go and linearise, because we're going to have some options and we need to compare, so we need some information, and the way we're going to compare is with our R value. So calc, regression, linear reg, list 1 and list 2. I'm going to copy the residuals into list 3 because I might want to draw a residual plot to see whether I need to linearise as well. That gives me some more information. And then I go OK. So then I've got some information given to me. I'm just going to write that down here. So from this, if I try to do a straight line, so straight line, it tells me that the equation would be y equals negative 49 x plus 1633.5, and my R value, which is the key thing here, negative 0.963074. So this is the R value. It's one of the key things we're going to look at. So go through this way to draw your scatter plot. You get this information along the way which we need. Now when you're doing this, always write this stuff down just in case this is your best option. And then you don't have to go back and redo it. Alright, so then we go OK, and you can see now draws our scatter plot for us. Now when you're looking at this scatter plot, immediately what can you What do you think when you look at that?
It's not super.
It's not super linear, is it? So it probably does need some transforming. All right, how else can we?
So
Yes.
my A and B was mixed around, but they were the right numbers, but they were, my A was,
Depends on how your calculator's set up. So I'll go back to this. This is, yep, here I'll show you analysis, regression, linear X. Go, okay, so see up here, at the top, mine says y equals ax plus b. There's a drop down where it swaps it around. And it swaps the a and the b around. Why it does that, I don't know. So maybe that's what it is, Alexis.
it's fixed.
All right, cool. All right, done. All right, so construct a residual plot. So if we go to residual plot, what are we going to do? We're going to plot list 3 against list 1. So we go up here, where are we? Don't have to get into the screen here. Analysis, oh there we go. What do I want to plot? This one here, click on it. I want an XY line, and I want list 1 and list 3. And then I'll go to set, and there it is. Any pattern? It is a pattern, isn't it? It does look like a parabola, doesn't it? So there is a pattern there. So both of those plots would suggest that we need to transform the data. So let me go back to our scatter plot. That's not what I want.
How do you get to that?
How did I get to that?
Yeah.
All right, I clicked on this icon here, this one.
Say that.
Clicked on that one, and this is what came up, and I changed my type to XY line.
Oh, the little thing XY.
Yep. And then
No.
X list 1, Y list 3.
No.
And then set.
Yeah, but nothing's coming up.
Yeah. All right, so if nothing's coming up, try this on the end here. All right, we can go back to regression, linear rank, 1 and 2, okay. Okay, that's not what I want. What have I done? Yes.
Line broken.
Oh, that's beautiful. I'll have a look at that later. All right, this was our first one that we looked at. So we'll look at the curve. So it's kind of curving around like this. So if we've got our circle coming around, it's that top right-hand corner. Now, in the top right-hand corner of the circle of transformations, bring it up, there we are. Here's the top right-hand corner of our circle of transformations, and it's saying here for us to try either the y squared or the x squared. So our circle of transformation says try x squared or y squared. So what that means is that we're going to transform our list 1 here for the x squared, or transform our list 2 for the y squared. And I'll show you how to do that in just a moment. Alright, so I'm going to try the x squared one first. So let's go back to our calculator. So we're interested in what's going on up here. And we want to transform, so x squared is list 1, EV, remember? List 1. I want to transform that by squaring it. So I can do a whole column all at once. If I go over here and I'm going to put this stuff in list 4. If you then, at the bottom, see how there's this thing that says cal? If you go down there, click in there. Cal, what do I want to cal? I want to calculate something. What do I want to calculate? I want to calculate list 1, which is here. I want to calculate those numbers squared. So I want to multiply these list 1 numbers by themselves and put the answer in there. So I've now got to find where it says list 1. So we go to the keyboard here, and there's some screenshots and that on your sheet there that shows that. Go to the keyboard.
Where does it say catalog?
Right. See how there's a little arrow, down arrow here?
Yeah.
Click on that down arrow.
Yeah, it's catalog.
Catalogue. Then you can jump to the L's by clicking on this arrow here till L comes. Jumps to the L's. Scroll down. List 1. What do I want to do with list 1? I want to input it. Then what do I want to do with it? I want to raise it to the power of 2. And then I want to execute that. Alright, so whatever you put down in that calculate row at the bottom, it will do that calculation with all the numbers that you've asked it to. Alright, you with us? We're all together, are we? We're all following? Alright, so now we're going to calculate, now we're going to graph the transformed data. So the transformed data for our, we want x squared, we're going to put the x squared. So list 4 is what we're going to put in as our x when we calculate our transformed. Alright, so up here, calculate regression linear reg. So the X list this time is our transformed list, which we put in 4. Okay. Right.
But Y stays as 2, yeah?
Y stays as 2. So we're going to graph list 4 and list 2. Yep. Okay. There's some information. I'm going to write that down because we might need that. Colour will I write it in? Purple's good. So our transformed. So our transformed, our A is negative 4.9, so Y equals negative 4.9. Now here it refers to it as X, but remember we squared it, so it's X squared this time. So that was our list 1, list 4, it's there, plus 1559.998. And our R is negative 0.999998. Now the key things, as I mentioned before, are these R's. Now what do you notice about this R compared to this R?
They both have
Both have a 9 at the start.
One goes 99998.
One goes 99998. Yeah, what are we looking for? Both are negative numbers?
Both are very close to 1.
Both are very close to negative 1.
Negative 1, sorry.
The one that's closer to negative 1 is the
Transform.
transformed data. So that's how we know whether we're going to use what we're going to use. This one's closer to negative 1 than this one, so this is better.
Is it just closer to a whole number?
remember R
Or
squared,
you want
R
either positive
values.
one or negative one.
What R values between -1 and 1. Our R values is somewhere in there. Closer to -1, the closer to 1, the better the fit. The negative tells us that it goes that way, the positive tells us it goes that way. Yes, am I right there?
Yes. Yes.
So we know that this one's going down and it's hidden there now, but that's what it looked like. So now when I press OK, it's going to give me the plot of our transformed data, so we can have another look. Whoops, forgot to turn off the previous one, didn't I? See this previous reg, got to turn it off. I keep forgetting to turn it off. Alright, calc, regression, linear reg, list 4 and list 2. There we are. Okay. Why is it not doing that? Don't you love it?
Very smooth.
Oh,
Tutorial smooth.
I'm so good at this, aren't I?
It's like your teacher.
Lucky. Alright, I'll try it this way. There we go. Look at that. Look at that. There's our line. Now what are we on? Calculate, regression, linear reg, list 4. Okay. Okay, there we are. Finally got it.
Now we're going.
Now what do you notice about the regression line and the points?
They're pretty like
Pretty much right on, aren't they? Pretty close to -1.
good.
All right. So, let me rub this off over here.
Is there much longer of an explanation?
Not much. Pretty much done with that.
Okay, that's good.
All right. So we've got our suggestion, x squared, probably not going to worry about trying the y squared, this is pretty close. So what's the next bit says? So linearise the data, done that, fiddle this squares line. All right, so I need to find what I've written here, part B. I've got y equals -4.9 x squared plus 559.
Yes.
Let's go 60, round it off. Now, don't forget, we need to write our equation in terms of our variables. And y was the height, yes?
Yes.
And x was the time squared plus 1560.
What was A?
Minus 4.9. I think. That's what
Like
I've
the
got.
answer. Oh no, A was.
All right. So there's part C says the height after 3.4 seconds. What do we do?
Substitute.
Is what we do. -4.9 times 3.4 squared plus 1560. Put that in our calculator. And because I've prepared one earlier, you get 1,503 metres.
Oh boy.
Oh boy, yeah. Oh boy.
That was just one example.
One example.
And now we're doing 3 more.
No, we're not
Just
doing 3 more. Over the next few lessons, we're going to do different types of transformations.
Gotcha.
So we're just looking at squared transformations today, and we'll look at some of the others over the next few lessons. All right, so all I've done there is exercises 5A and B.
We're on to the 8s. I mean the 5s.
And that's it then. Don't forget, as Sam said, like and subscribe.
This is next.
50